Why, hello there, lovely one. It's me, Helen the Great, and we are going to plot a function. Now, the first thing we need to do whenever we're plotting a function is to determine what the shape is. Once we've done that, we need to figure out if it has asymptotes, and we'll know that by the shape, and what are the intercepts. Once we have all of that information, we can plot it. In order to determine the shape, we need to look at the position of x, or what's happening to x. In this case, x is in the denominator, so we know that the shape is going to be a hyperbola. And a hyperbola is broken up into two pieces. Why is it broken up into two pieces? Because it has two asymptotes. So it's either going to look like this, or it's going to look like that. Now, yes, we've got the general shape, but we need to determine, is it going to be in the first and third quadrant, or in the second and fourth quadrant? And the way we determine that is we look at the value of the numerator. If the numerator is positive, then it will be in the first and third quadrant. But if it's negative, like this one, it's going to be in the second and the fourth quadrant. So that's the shape. Now, because it's a hyperbola, we know we're going to have two asymptotes. One where y can't equal something, and the other one where x can't equal something. In grade 10, it's quite easy to find the asymptote that goes through the x-axis, because we don't do anything to the denominator, we just keep it as x. If you think about it logically, we can never divide by 0, so that means x can't equal 0, because in that case we would be dividing by 0. You'll see over here that I put two asymptotes in preparation for this very thing. So let's put that one over there, move it over slightly, to show that x can never ever be equal to 0. But now we need to figure out what our y asymptote is. Let's think about it a little bit. Can that fraction ever be 0? No, it can't ever be 0, so that means y will never ever equal 1. So let's select this asymptote, try and do it as close as possible, and move it up to where y is equals to 1. So somewhere over there. And remember, I do need to label my asymptotes. Whoopsie, let's get the pen out. In this case, x is equals to 0 and y is equals to 1. We've labeled them like that because we're labeling the equation of the asymptotes. Now, remember we said it was in the second and the fourth quadrant, and the trick is we can actually plot that right now. Why? Because it doesn't have to be absolutely accurate. We just need to make sure that it never goes through the asymptotes and it never touches the asymptotes. And let's put one down over here. But now we have an important point that we haven't labeled. We can see we've got no y-intercepts, but we do have one x-intercept. So how do we determine the x-intercept? Well, I'm just going to label my calculation as x-intercept. I need to make y equal to 0. So 0 is equals to -5, and this question requires just a little bit of mathematics. You have to think outside of the box, because we've got to get x out of the denominator. So I've started by moving 1 over, and now I'm going to multiply by both sides by x so that it becomes -1 is equals to -5, which means x is equals to 5, so our x-intercept is going to be 5 and 0. Let's label it over here, 5 and 0. In terms of marks, I would mark that both asymptotes are marked with the equation of the asymptotes, that I've got the plotted x-intercept, and that the shape is correct. Even though most of this has been drawn freehand, the axes haven't been, but everything else has been done freehand, and it's not very neat, but it's neat enough. I would still get 4 out of 4 for that question. Why? Because the shape is correct. I've got the x-intercept. I've got the 2 asymptotes. And that's all you need to do. Much love.